All right, good morning, everyone. Welcome back to another class. So, as you guys should know, we have completed 3 chapters so far. We have 3 from 11, that should be about 9 more remaining. If my calculation there is correct. 8 more remaining chapters. Yes. So, so far, we've covered what is the basics of a computer. We looked at input devices. We looked at output devices. So today we're going to be starting the fourth category of hardware, and that is going to be primary memory, or we can just say memory. So we'll be looking at what are the types of memory today, and basically also how data is measured. That's what we're going to be looking at today, and hopefully if we have some additional time we could make a start on secondary storage and see where we go from there. So to get us started with primary memory, if anyone can remember, does anyone remember where I said is the location of the memory? Anyone remembers me mentioning anything like that? No one? Well, this here is an example of computer memory. The memory that you will find in your computer, your laptop, your desktop, or whether if it's your phone or whether it's your console. It looks something like this here. Some of them, they allow you to basically put it into the computer. There's a slot on the motherboard, like what you see in here, so that you can put that memory into the computer. But on smaller devices, that memory is soldered onto the board of the device. So for example, this one here, yes, this could be an example here of memory that is soldered onto this board here. So it's basically that chip, because if you look at these examples here, the memory is basically these black chips as was storing the information, and the green part that you see is basically the electrical connections that would facilitate the connection between memory and the computer. So this is what it looks like inside your desktop, inside your laptop. This is what it's going to look like. But inside of smaller devices like your phone, your tablet, and so on, it's going to look something like what you're seeing on the screen here. It's going to be soldered onto a board because you need to take up lesser space in those devices. So that's why you cannot change the memory in your phone. You cannot change it in your tablet because it's soldered onto the device's board. Whereas in your laptop and your desktop, that's why you can change the memory, because it's just plugged into the device, plugged into the computer. So let's get some description, some more information about what is memory. And the first 2 paragraphs, let's start back from the top. I think we have finished. Aquila Gonzalez, can you read for us the first 2 paragraphs? Are you guys hear me?
Yes, sir.
Yes, sir.
All right, seems we don't have Aquila today with us. Alian?
Some of the data you put into a computer will be needed right away for processing, while other data may not be needed for long periods of time. Therefore, different methods of storage are appropriate for different uses. The main purpose of the CPU is to process instructions as quickly as possible. Main memory is located directly on the computer's main circuit board so that data can travel quickly to and from the CPU to be processed.
Very good. So we have different types of data. We have data like your music files. You have data like your pictures, your assignment files, and so we have different types of data, different types of documents on our computer, on our devices. Now, based on the first paragraph, there's the need for those type of data can vary. For example, um, when you're playing, say, say for example, a picture. You take pictures of yourself. How often would you need that data? How often would you have the data on your computer, you have pictures on your computer. How often would you need to access those pictures? Or how often do you guys look at your pictures?
Sir, can you repeat?
How often do you look at pictures on your computer?
Sir, once a year.
Good. I like that.
Never.
Never. Good. And only those persons who like to themselves, they might go on the computer and every day they check out the pictures and stuff.
Yes, sir. I was just about to say that.
So it varies. So
Yes, sir.
different types of data, your music file, because sometimes some persons got music on the computer, they don't play those music at all. Only maybe only on the weekend they might play some music on the computer, and that's about it. So certain types of data, you're gonna only use it now and then. So you might use it once a day, once a week, once a month, and so on. So you do not need it for long periods of time, those types of data. But there are some types of data that you need right away. Types of data that you need right away are going to include, anyone has an idea? What do you think are some types of data you might need right away? No one? Alright. What about your when your computer is on? Remember we looked at this on the software. When your computer is on, what software is it using when the computer is on? What type of software? Or when your phone is on, what type of software is it using? No one? We revised this like 2 times.
Sir, can you please explain? My internet was breaking up for me.
The types of software when your computer is running, when your phone is on, what type of software is it using? Or what software is running all the time when your computer is on? It should be a simple question. What software is running in your computer every time it is on?
Your system software.
The system software. So what system software are you currently running?
Sir, like, do you mean your operating system? Or like...
Yes, your operating
Oh,
system.
well then, for me it would be Windows 10.
Good, Windows 10. Good. So some of you using a computer with Windows 10 operating system. Some of you might be using your phone, so you either using Android, using iOS. So those operating system, their data is needed right away all the time. That type of data, your operating system, it is needed all the time so that your device can function all the time. It can function smooth all the time. Because if those type of data were treated like your music file and your pictures and so on, then your computer will not function properly. So certain types of data you need right away. Like for example, the data that is going to run your computer, the data that is going to play your games, the data that you're going to run an application. You need those right away. But certain other types of data, you do not need them right away. So with those type of data, where they are stored is important to understand. Where do we store data that we do not need right away? And where do we store data that you do need right away? Well, the data that you need right away is going to be stored in memory, and that's the chapter we're looking at. So memory, that stores data that you need right away. Please remember that. And the term memory also refers to main memory. That's something else you guys should remember. There's actually three names that you should remember: memory, main memory, and there's another one. I think later on we're gonna come across it. Can't quite remember it at the moment. But there's memory and then there is main memory. They refer to the same thing. And that stores the data that your computer needs right away. So if you were to draw an image of this here, say for example, this is your motherboard. And remember, this is your CPU. Your CPU. And then next to the CPU is your memory. And then, so this is memory. And then connected to your computer, you're gonna have a hard drive. This is your hard drive. So we have the two types of storage here. If you guys can remember the categories of hardware, memory is the fourth category that was mentioned, and storage is the final category. So those are like two types of storage. So the data that you need right away is going to be stored into memory. And the data that you need, that you do not need right away, that is going to be stored in the storage devices or your hard drive. So let me give you an example of a scenario that can happen. So when your computer is running, or when your computer is off, your operating system, OS, so in this case here, Windows 10, is going to be stored on the hard drive. This is where it is currently being stored, on the hard drive. Now when you turn on your computer, when you press that power button, you turn on the computer, you turn on your phone, what's going to happen now is that that data, that operating system, gets pulled into memory. So the data, the operating system gets pulled into memory because your CPU needs that data to process it. So the CPU won't pull it directly from the hard drive. It won't do that because the hard drive is not fast enough. Your CPU processes data very quickly, so quickly that you need another type of memory to basically keep up with it. And that is the memory, or the main memory. That is why we have that memory in the computer, to keep up with the CPU. So the data is pulled into the memory from the hard drive, from the flash drive, wherever you have it stored. And then the CPU now is going to look at that memory, the data in memory, and process the information, process the data. So if you guys can remember IPOS, we're at that processing stage. The CPU is processing the data. Where is it getting the data to process it? From memory. You guys think you understand all of that? Sounds like you guys confused.
Yes, sir.
You guys understand, or you want me to go it over again?
Sure, please go ahead again.
Alright, let me undo. Good. So remember the first paragraph mentions, the first paragraph here, it mentions we have basically two, it's not really two types of data, but it's how we use the data. Sometimes we have data that we do not use regularly, like your pictures, your music files, but we have data that you need to use regularly, like your operating system data, the application data, and so on, so that your computer can run, so that your computer can work, and so on. So you have data that you do not use regularly, and you have data that you do use regularly. You guys following up to there?
Yes, sir.
So the data is normally stored on the storage device. So that's the fifth category. If we look back at the categories of hardware, remember we have 5 categories. So we have the storage media, the storage devices. So your data is going to be permanently stored on that storage media. So in this example, we're using the hard drive. All of you that are using a computer, a laptop or a desktop, it has a hard drive inside that is permanently storing that data. Now, your computer needs to process that data in order for your computer to work. In order for your computer to work, it must process data. So, in order for the CPU now to process that data, because remember the CPU is what does the processing, it needs access to the data. So how is it going to get the data? Is it going to go directly to the hard drive and get the data? No. I mentioned the CPU does not do that. It does not go directly to the hard drive. Why? Because the hard drive is too slow. It's not fast enough. The CPU, by the time the CPU does something, it's waiting on the hard drive to send something. So it will never meet the speed of the CPU. It's going to always be waiting. So you basically need something that can keep the data so that the CPU can get it whenever it wants it. And that is where the memory comes into play. So instead of the CPU going directly to the hard drive, the data is going to go to memory, it's going to be stored into memory, and then the CPU now is going to look at the memory and pick out the data that it wants to process. So the same operating system, when your computer starts up, it's going to be transferred into memory. And when it is in memory now, your CPU is going to look at the data in memory, not the hard drive, and work with that memory, and work with that data. So another example is that when you want to play a music file, or when you want to look at a picture on your computer, it's the same process also. Your computer does not go to the hard drive. Your computer does not go to the hard drive to get the data for your music file, your pictures. So say for instance you're opening a music file. If you can spell music. Yes, you're opening a music file on your computer. Now what does the computer do? So once again, the CPU needs to process that file in order for you to hear the sound, in order for you to hear that music. So how is it going to get the data to process it? Once again, it's not going to go directly to the hard drive. Why? It's too slow. So what it's going to do, same thing once again, is going to transfer the music file to memory, and then the CPU is going to look at memory. Look, I see the music file inside of memory, so I'm going to process it, see what is it about. It's a music file, play the music file. And when you finish, it basically clears it out of memory, and that's basically how your computer functions. and how it uses memory. Did that help? Or are you guys still confused?
Sir?
Yes?
It helps, sir.
Sir, it kind of helps.
Alright. Well, as we go on, hopefully it makes a little more sense as we describe the types of memory a little more. But for now, just remember the IPOS cycle. That's the important thing to remember. This IPOS cycle here: input, processing, output, and storage. Where does the computer do the processing? It uses the memory to do the processing. It collects the data from memory in order to process that data. So the second paragraph, the main purpose of the CPU is to process instructions as quickly as possible. So that is why the main memory is located on the motherboard, and it's actually not too far from the CPU. If you were to look at an actual motherboard, okay then. Have you guys hear me?
Yes, sir.
Alright, let me know if in time you're not hearing me, because once again I'm using school's Wi-Fi and I'm not sure. Sometimes I don't understand how this is possible.
Sir, that happened to me not too long ago.
Yeah, so either the internet is too slow, or there's restrictions on the internet at a certain point in the day. I don't know what's really happening. Do I have a picture of a motherboard on my computer? Supposed to. Yes. Yes. So this here is a picture of a motherboard, and as mentioned, this is where the RAM is gonna go. The memory that was actually the other name. So memory, main memory. These black and yellow slots that you see at the bottom here, that's where the memory will go. And if you notice how close it is to the CPU is just above here. So when the CPU wants to process data, the data is basically going to go back and forth this way. So the data is going to be connected, your hard drive is going to be connected to one of these ports at the bottom here via cable, and then the data is going to come in, go to memory, stop it here, and then whenever your CPU needs it, it's just going to go back and forth between the CPU there. That's basically what your computer is doing all the time to process data. Alright, let's go on to the next two paragraphs. And we're going to have, let's see, Akila Davidson. Are you with us?
Yes, sir.
Can you read for us?
Sir, who did you call to read?
Akila. Akila,
Yes, sir.
can you read for us the next two paragraphs?
Main memory is located directly on the computer's main circuit, so that the data can travel quickly to and from the CPU preprocessor. Data is stored at a specific memory location called an address can have its address content accessed to be to be read from
Can you speak up a little, Akila?
The largest amount of data which can be located to be processed is called the work. There are different types of computer memory. Let us look at some examples of computer memory and location.
All right, very good. So, as mentioned already, the first line, the main memory is located directly on the computer's main circuit board so that the data can travel quickly from the CPU, from and to the CPU so that it can be processed. So, once again, the image, the CPU and the memory, they're right next to each other so data can go back and forth to be processed quickly. Now, two terms here that you should remember. Two terms. You have the term address and you have the term word. It's important for you to remember what these two terms are. An address refers to a location of data in memory. Just like how when the post girl or the postman comes to deliver a letter to your home, to know where you are located, where you're living, they look at your address to find where you are. Maybe you're living at 54 Princess Street, Georgetown. That is your address. So your memory now also has addresses so that the computer knows, or the CPU will be able to know, where a specific type of data is stored. So for example, just say for example, this is the memory. The memory could be divided up, something like this here. Just use it as an example. And we can say that A1, that's that address, has a music file. A3 has a picture. A5 has a Word document. So when the CPU now, the CPU at the bottom here, the CPU wants to process the music file, is going to say, look, I want that file that is in A1, send me that piece of data. Or you just clicked on the picture and you want to open the picture, it's going to tell memory, look, give me that picture that is in cell A3 or address A3. So that is how it knows where to store the data and how to locate the data. You guys following?
Yes, sir.
Alright. I think that should have been simple enough. So it's just like how you have an address, your data has addresses also to be located. Now the next term you should remember is what is a word. Or you can also say what is a word size. Sometimes they also call it that, the word size. So a word or a word size is the largest amount of data that you can move or process at the same time. So later on we're going to be looking at sizes of data later on in the chapter, gigabytes, terabytes, kilobytes, and so on. That's basically what it's referring to. How much data can it move and process at the same time? So for example, when it comes to data is usually the smallest amount of data is measured in bits. We'll talk about this more later on, but just remember this here. The smallest amount of data is measured in bits. So one piece of data is going to be 1 bit. 2 pieces of data is going to be 2 bits. And 3 pieces of data, 3 bits, and so on. So a word is how much of those bits you can group together to move together at the same time and process at the same time. So for example, you can actually see this on your computer when you go to settings if you're using Windows 10 you go to System, and you go to About. If you notice here, the system that we are using, it is 64-bit. So that means it can move 64 bits of data at one time and process 64 bits of data at the same time. So instead of doing it one by one, so instead of sending say for example, instead of just sending one piece of data over, like this here, sending one, and then sending two, and then sending three, and then sending four, instead of sending it one after each other, what it's going to do is going to group it together. So 1, 2, 3, 4, all of that grouped together and send as one. So that way now, you send more data and more data gets processed at the same time. So going back to the term, word size or word refers to the largest amount of data that you can move and process at the same time. So basically, how much can you group together at the same time, to move together at the same time, to be processed at the same time. You guys following?
Yes, sir.
Yes, sir.
All right. So those are the two terms there that you should remember. All right, let's move on. So now we're going to head into what are the types of memory. So we basically have, let's see, 3 types of memory. Yes, we have 3 types of memory. We have RAM, random access memory. We have ROM, read-only memory. And then we have hybrid memory. So you have 3 types of memory. And remember, if you can remember above, I was saying that memory has 3 names. So please remember this here. Memory has 3 names. So it is memory by itself, or you can say main memory. And it also refers to RAM, random access memory. So those 3 things, those 3 terms, they refer to the same thing. Memory, main memory, RAM, they usually refer to the same type of memory. So let's look at what is random access memory. And our next reader, Asifa, are you with us?
Yes, sir.
All right, can you read the next 2 paragraphs for us?
Inside a computer, you will find one or more memory chips called RAM, random access memory. These hold the temporary operating instructions for the computers, its programs, and the data. This is the place where the CPU receives the instructions and data it needs to do its job. The advantage of RAM is that the computer can access data held in RAM almost immediately. The major disadvantages is that RAM is a volatile. Data held in RAM is lost when a computer is turned off or malfunctions. This is why we need to use other medias to store data.
Great. So once again, the first type of memory we are looking at, random access memory. So it's important for you to remember what RAM stands for, random access memory. And as mentioned, this refers to that memory that you're going to see here on the screen. These slots that you see in here, the chip that goes into there to store the temporary instruction, that is RAM. So if you search your computer memory, hopefully it works this time. So if you guys can remember that green chip that I was showing you earlier, that is the memory, the random access memory. So as mentioned, it stores the temporary instructions. So whatever your computer needs right away in order to function, the memory, the random access memory is going to store that data. So as the last line mentioned, this is the place where the CPU receives instruction and data to do its job. So what is the advantage of RAM? Well, as I had indicated in the drawing, we use RAM because the system needs the data to access it. The system needs the data immediately in order to work. It needs it right away. So it will not use your hard drive or your flash drive to get the data. It is going to use your RAM or your memory or your main memory in order to get the data immediately in order for it to work. But the disadvantage of RAM is that it is volatile. What does volatile mean? It basically means that if it loses electricity, it's going to lose the data inside of it. Have you guys, if you shut down your computer, say you have a game open on your computer, or you have an assignment open on your computer, and you just suddenly get blackouts, do you guys expect to see that game or that assignment on the computer when you turn it back on?
No,
So,
sir.
No. So it doesn't matter what you had running on your computer. Once you get blackouts and you turn on back your computer, we don't expect to see it back because we know it won't come on back. Now, why is that the case? Why don't we see the game that we had running? Why don't we see the assignment that we had open? That is because the data was inside of RAM. The data was inside of memory. So let me put back a drawing. So because this is the CPU once again, this is memory, this is your hard drive over here. So because the data moved from your hard drive to your memory, because remember the CPU needs to work with data in memory because memory is faster. It needs it immediately. Your assignment is inside of your inside of memory. So whenever you lose power, the assignment disappears. Whatever game you had running, it disappears because it was inside of memory. That is why they would tell you, when you're using a computer, ensure you save and then shut down your computer. You're saving so that the data in memory gets stored into your hard drive. The assignment you're working on, whenever you save that Word document, it's actually saving it to the hard drive. The game that you're playing, when you close it, the data is going to be stored into your hard drive. The picture that you were looking at, when you finish editing it and so on, and you save it, it's going to be stored into your hard drive. That's why they would tell you, ensure you're constantly saving, and then you shut down your computer properly, so that everything gets stored properly into your hard drive, so that when your computer starts up once again, it's going to pull that from the hard drive and put it into memory. So it's like one cycle that keeps going on all the time. Data gets pulled from the hard drive into memory so that your computer works on it, and when your computer is saving it, it sends it over to the hard drive to be saved permanently. You guys following and all that?
Yes, sir.
yes, sir.
So that's what it means to be volatile. When you lose power, you lose the data that is inside of it. So that's the disadvantage with RAM there. So that's why you constantly have to be saving. So that's another term you should remember. what does it mean to be volatile? When you lose power, you lose the data that is inside of that memory. Now the next type of memory is ROM, read-only memory. Let's have, let's see. Alkisun, could you read that for us?
Yes, sir. Read-only memory, ROM. When a computer is made, basic input or output instructions are put on ROM, read-only memory, chips. These instructions can be read but not changed, non-volatile, and are available every time the computer is switched on.
Very good. So you can think of ROM, read-only memory, like the opposite of RAM. When you think of RAM, think of it being temporary. Because remember, it's volatile. So whenever you lose power, you lose the data inside of it. And when you hear ROM, think permanent, because it is non-volatile. Notice this here, it's non-volatile. So what that means, it does not need electricity in order to save the data. You could turn off the computer, and when you turn it back on, you are still going to see your data because it was stored on a ROM chip that is non-volatile. So remember, ROM is more permanent. It doesn't require electricity, whereas RAM is temporary. It is volatile. It requires electricity. So what is ROM used for? Well, ROM is used to store basic instructions. As this here indicates, basic input and output instructions. Any of you ever wonder, how does your computer know to start up when you press that power button?
So when you press a button, it signals something.
Yes.
Yes, sir. It signals something to the computer system.
Good. Sounds like you have the right idea. So what happens?
Sir, because like
Yes.
the button phones, when you buy button phones and you take off the button cap, you see some shiny thing that's like the green chips.
Mm-hmm. All right, so that there is ROM. This here is RAM. This is your CPU. And this here is your hard drive. And this is your operating system. This has Windows 10 on it. But so how does your computer start up? What actually happens? So over here you got the power button. Imagine that as your power button. So you press this button over here, power, and what happens? Well, when you press that button there, what actually happens is that a signal is sent to a ROM chip. This is when the computer is starting up. This is when the computer is starting up. A signal is sent to this ROM chip. Now this ROM, remember, it's a type of memory, so it has data inside of it. What type of data? As the paragraph mentioned, it has data with basic input-output instructions. And if you guys put those letters together, have you guys ever heard of BIOS? Anyone ever heard about the BIOS?
No, sir.
No?
No, sir.
Well, that is basically some instructions that your computer follows in order for it to function at a basic level at when your computer is starting up. So this ROM chip that is seen at the bottom here stores those BIOS instructions, those basic input-output instructions. So when you press that power button, a signal is sent to the ROM chip. So one, you press the power button. Two, a signal is sent to the ROM chip. And what the ROM chip does now, it checks what instructions it has in it. What it's going to do, one of the instructions is actually to check the entire computer to see if it is working. So you're going to check the hard drive and basically say, hard drive, you working? You can say, yeah, I working. So you check that off. You're going to go to the RAM. You say, RAM, you working? Yes, I working. Check that off. CPU, are you working? Yes, I working. So check that off. So that's one of the instructions of ROM. It's to check everybody, ensure they are working. Now, so for example, any of you ever heard a beep sound when you turn on your computer?
No,
Yes, sir.
sir.
Only desktop persons would actually hear this. When you turn on your desktop, beep sound.
Yeah, yes, sir.
Right. That beep sound is actually the same process that I'm describing here. That beep is indicating that everything is working, everything is good. Your CPU working, your memory working, your hard drive working. So if any point in time in your future, you see that your computer is not turning on, well, this is for desktop persons. You see your computer is not coming on, you're actually going to hear different beeping sounds because it's basically trying to tell you that something is wrong. That's what technicians, they would try to figure out what that sound represents, and they would try to fix that part of the computer. Sometimes the sound might tell you that the hard drive is bad, the CPU is bad, the memory is bad, something is bad. But once you hear that one beep, it means it tested everything and everything is working. So that's one of the instructions of the ROM chip. After it finished checking everything, everything is working, everything is good, what it's going to do next is actually look for the operating system. So that's how your computer starts up. That's how the operating system gets loaded into the computer. The ROM chip actually looks for the operating system. So this ROM chip here is going to go over to the hard drive now. So that's going to be 3. Looks for the operating system and then pulls that operating system into RAM. So you guys see how everything interconnected?
Yes, sir.
So all of the hardware, all of the software, this is how all of them work together. You press that power button, it sends a signal to ROM, follows the instructions in ROM. When it finishes doing everything, it's going to look for the operating system. It's going to look for Android, it's going to look for iOS, it's going to look for macOS, it's going to look for Windows. When it has found it, it's going to pull it into memory. It's going to pull it into RAM, step number 4. And that is when your operating system takes control of your computer. So when you see Windows is starting up, or you're seeing that Windows icon, that Windows logo, or you see Android, or you see that Apple logo starting up, that is the operating system actually being transferred into RAM. And when it has finished being transferred into RAM and you get to use your computer, that is when the operating system is controlling the computer. So when you see that logo, that is when it is transferring. And when you get to use the computer, that is when it is taking control of the computer so that you can use the computer. You guys following and all that?
Yes, sir.
Alright. So remember the 2 types of memory, RAM and ROM. Remember, RAM is volatile, meaning if you lose electricity, you won't get any data. ROM, it is non-volatile, does not require electricity. Alright. Now the next type of memory is the hybrid memory. Hybrid, let's have, let's see. Chansey.
Yes, sir.
Can you read for us the next paragraph, hybrid memory?
Yes, sir. Hybrid memory. Recently, as memory technology develops, line between RAM or RAM and RAM ROM has become blurred. Now, several types of memory combine features of both. These devices do not belong to either group. They are called hybrid memory devices. Hybrid memories can be read and written as desired, like RAM, but maintain their contents without electrical power, just like ROM. Flash memory is a variation of ROM device that is typically used to store code.
Good. So, hybrid memory is basically a combination of RAM and ROM. It took the advantages of both of them and made it into one type of memory. So, for example, um, the disadvantage of RAM is because it is volatile. Once you lose power, you can't get any more data. But you can read and write the data to RAM anytime you want. That's this part here. Um, this line here, you can read and write data as desired whenever you want to. That is RAM. That's the advantage of RAM. ROM doesn't allow you to do that. ROM is actually a one-time thing. Once you put data on ROM, that is it. You can't remove it anymore, depending on the type of ROM. So that's the disadvantage of ROM. Now, but what they did, they took the advantage of ROM, and that was it being non-volatile. So they took the non-volatile from ROM, and they took the ability to read and write at any time from RAM and created hybrid memory. So they took the advantage of both. So just to remember that hybrid memory allows you to read and write at any time, and it is non-volatile. You can see the data at any time without electricity. It keeps the data without needing electricity. So an example of hybrid memory is flash memory. As an example of hybrid memory, flash memory. And you guys are actually familiar with this here. How many of you have a flash drive?
I do, sir.
How many of you have a memory card, SD card in your phone?
Yes, sir.
Good. So those are examples of flash memory. Your flash drive, your SD card, your memory card, those are all examples of flash memory. And if you think about it, your memory card, your flash drive, it stores the data without electricity. So that's the non-volatile part. And the RAM part, you can read and write data to it at any time you want. It doesn't restrict you and say that oh, you can only send over information one time or at a specific time and so on. So hybrid memory, the advantages of RAM and ROM, and the example is the flash memory there. Alright, I just want us to wrap up on how data is represented. Christian, could you read for us?
How data is represented. Everything everything that the computer does results from the turning on and off of different combinations of microelectronic switches called transistors, or its
Stable.
bistable devices. The off and on states of the transistors are used to represent zeros and ones that make up the binary number system. These zeros and ones are known as bits, binary digits. A bit is the smallest chunk of information or any piece of data that a computer can work with, either binary 0 or binary 1. The more bits a processor can use, the faster it can compare, work things out, and do the more memory it can access easily. When you use a computer, millions of switches are continually being switched on or off by an electric current.
Very good. So, how does your computer function? How does your computer work? Well, in a nutshell, what your computer is basically doing is turning millions of switches on and off constantly. That's how your computer is basically working fundamentally at a very low level of understanding. It's basically turning switches on and off constantly. And these switches, we call them transistors or bistable devices. The word bistable basically means there's two states, either on state or off state. So that's like the switch in your home. It can either be on and off. It can't be in the middle. If you do put it in the middle, it's still going to be, this light is still going to be either off or the light is going to be on. So it's either on or it's off. So that's what your computer is constantly been doing all the time. Now, how do we represent that on and off? Well, we use the binary system, because the binary system is only 2 digits, a 0 and a 1. So we use the binary system to represent that on and off. So binary digits, we call that bits. So you're going to hear this term a lot, bits. And bit is the smallest piece of data in the computer. The smallest piece of data. So, as mentioned, a binary is either a 1 or a 0. So a bit is basically either a 1 or 0. Are you guys hearing me?
Yes,
Yes,
sir.
sir.
At what point did you lose me? You heard all of that. You guys heard everything I said, or continue? What? Yes, you guys hear me now? Hello?
Yes, sir.
Yes, sir.
Alright, y'all see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
At what point did you guys lose me? Or did you guys hear everything I just said about bits?
Sir, I think we heard most of it.
Alright. Well, as I mentioned, a bit refers to either a 0 or a 1, and that is the smallest piece of data or information of your computer. So that's why we would usually say, if you guys can remember when we were talking about that word size, or that word, I was talking about 1 bit, and then when I showed you the settings, I showed you 64 bits. So 64 pieces of data the computer can process at any one time. Alright, so the bit is the smallest piece of data, the smallest piece of information. And this table here shows you how those data is, how we measure data. So please take down this information here. So we already know that a 0 or a 1 is a bit. Let me, yeah, I'm gonna write it right here. It's 1 bit, a 0 or 1. Now 8 bits is refers to 1 byte. 8 bit refers to 1 byte. It's right here. 8 bits refer to 1 byte. And then from that now, we add the words kilobyte, megabyte, gigabyte, terabyte, and so on. Now, how do we get all of that? We use some simple conversions. Let's see. A bit of technical information. let's continue with this from next week. There's a bit of technical information and I don't want to rush through it. And then you guys don't understand how to do the conversion. Alright, well basically to recover, review everything that we did, then we look at what is memory. So the main thing to remember is what is memory. It is a temporary storage of your computer that is used by the CPU for processing instructions. What are the types of memory? We have RAM, which is volatile and it is temporary, and we have ROM, which is permanent and it is non-volatile. And then we have hybrid, which is a combination of RAM and ROM. And then there's a few terms that you should remember. What is an address? What is a word? What is a word size? And so on. Any questions before we end?
No, sir.
Alright, well we're going to end here for today. If you guys don't have any questions, enjoy the rest of your day.
Bye, sir.